that better?
Yep.
There you go.
Woohoo. Well, our 0.70 was still correct at 2 decimal places, right? So we're 1.69.
X.
So I only typed in a 0.5, forgot a 0.5 in the whole calculation. You can see how it throws you off. Minus 142.47. Okay, so now let's talk about what are these slope and intercept telling us? And do they make any sense with respect to what we're trying to do here? So let me try picture mute there. The slope and y-intercept in this case are they're very specific, they're very applied. So we want to talk about what they mean, what they're telling us, okay? So if you recall, slope is a ratio of the change of two quantities, right? It tells us the change in the y direction over the change in the x direction. So this tells us, what's going on, difference up and down. The denominator is telling us what's going on as a change back and forth, right? We always look at slope as a fraction, right? Okay? So if our slope in this case, which number there is the slope?
1.69.
1.69, thank you. So if our slope here is 1.69, it means that, and our units were, let's see, the y was the, x was bare length in centimeters, is that right? Yeah. And y is bare weight in kilograms. Okay, so the slope is telling us, right? Remember, if you don't have a fraction, you make it one. It means for each additional centimeter of length, the bare is going to weigh an additional because it's positive, right? X gets bigger, y gets bigger, okay? 1.69 kilogram. So if I asked you to interpret the slope, so everything goes back to the problem. Bare weight, bare length. Bare weight in kilograms, bare length in centimeters. You with me? Yeah? So for each additional centimeter of length, the bare weighs an additional 1.69 kilogram. In general, right? In general. And then, how about the intercept? Let's talk about the intercept. So the intercept here is negative 142.47. And you know that, all of our stuff is going on like over here in the first quadrant, okay, which is usually in regression where it happens, not always, but usually. So at the y-intercept, what's the value of x? 0, good. So, and what is x? Bare length. Does a bare with no length make any sense? No. So we just write that. So what we're doing here is we've got a specific realm of the xy plane, the Cartesian plane, okay? But the y-axis really doesn't make any sense with respect to our actual application. Are you with me? Okay? And we'll just note that. Sometimes it does, but sometimes, no, it's ridiculous. So, problems will say something like, interpret the intercept if possible, or what is the y-intercept? What is the y-intercept say if applicable, or what does it mean if applicable, or something like that. So if we interpret the intercept, we would say the y-intercept has no meaning here. Since bare length of 0 is impossible. That make sense? And I'll make sure that we get an example where the intercept does make sense. Sometimes there's actually a, like if you have like emissions, like if you've got a certain type of, I have a problem somewhere where if you have a certain type of emissions, then it results in some type of greenhouse gas, and you can have no emissions, right? If none of that pollutant or that chemical is getting released in the air. So that's an example where the intercept would make sense. Okay, so let's see. Okay, and then I think I put in your notes that with the R value, again, the stronger or the closer R is to +1, the stronger the positive linear relationship between the variables. The closer to -1, the closer the negative relationship between the variables. Both are good, okay? The closer R is to 0, the weaker the linear relationship between whatever the variables are, bare, weight, and length. Okay? So the next thing we might want to do, okay, we're already in 4.2. Okay. Let me talk about this. Okay. When we have our scatter plot, how do we know? Okay. How do we know that the line we've calculated is the best line? What does it mean to be the best line? You with me? I mean, is that line best? Or is that one a little better? Or maybe even that one? How do we know which one is absolutely the best? And this is a nice, anybody take calculus? This is a nice application of calculus. Because in calculus, what we want to do is minimize and maximize quantities, right? That's the first fundamental theorem of calculus. Okay, and these, the formulas that you see in your handouts that calculate the slope and intercept minimize a specific quantity. So let's talk about that. The thing we're trying to minimize here is the vertical distances between each point and the regression line itself. Okay? So here is the scatter plot of the bare data, and here is, it's from my calculator, and here is all of these vertical distances between each point and the line are called residuals. They're the error involved. Okay, so there's always error in whatever we do statistically. We expect it. It's just part of the deal, part of the gig. So again, each one of these visual or these vertical distances between each point and the line are called a residual. Okay, that one would be really small. That one would be a little bigger. And notice that some of them are positive and some of them are negative. Some of them are above the line, some are below. You find the residuals by taking the observed y, that's the actual data value that's in your data set, and subtract the predicted y at that value. So for example, let me gather my thoughts. In our data set, you know what? Let me show you how to graph the line, and then this will make more sense. Is that all right? Okay. So let's go back to our calculator real quick. Okay. So you've got your, if you hit graph, you've got your scatter plot on your graphics screen, right? You with me? And then if you go back to your home screen, you've got the output from the regression there, right? You need both these things to graph the line on top of the scatter plot, because the calculator is going to take this information and turn it into the equation and graph it with the line. You with me? Okay, so then you go, let me make sure I can remember how to do this. Yeah.
Second, quit.
Yeah, go second and quit, the button right next to it. Then you hit these buttons. You go the VARS button that's right next to clear, V-A-R-S. Oh, no, I'm already wrong. Go back. Sorry. First you go y equals, and you get your cursor. Okay, so what we're going to do is we're going to make the calculator grab that data on your home screen and put it in the equation editor. We could type this in, but it's much more fun to let the calculator do it. Okay? So where we want to end up is in that equation editor. So you hit y equals and get your cursor on the first y1 equals. You with me? Okay. Then you hit VARS 5, right, enter. Okay, so it grabbed that equation off the home screen and it put it in the equation editor and graph.